Hey everyone, welcome back to my YouTube channel. In today's video, we will solve another lead code problem step by step so that you can strengthen your coding skills. So let's straight dive in. Today we are going to discuss about another classical lead code problem, which is subarray sum divisible by k. In this question, we will be given an array and we have to find the number of subarray whose sum are divisible by k. So in this question, here is an example is given there is an array with elements 4, 5, 0, -2, -3, and 1, and k value is 5. So we have to find out how many subarray are there whose sum is divisible by k. So in this case, the solution is like 7 because you can count the number of array is like 4, 5, 0, -2, -3 is taking all the element. The sum of these are 5, which is 5 divisible by 5. So 1, then if we include only 5 and 5 and 0, we just have to make sure that the array is contiguous. Then the other array is 5, 0, -2, -3, then just 0, then 0, -2, -3, then -2, -3. So these are the 7 examples. Another examples are given, like 7 possible for this example. Another example is given in which the array has only one element, which is 5, and k value is 9. In this case, the answer, the output would be 0. So this is the solution of this question. This question can be solved in multiple ways, but the best possible solution, we can solve this question in O of n time complexity. So let's straight dive into the solution. So what I did basically, this solution actually looks very simple, like 4 or 5 lines of code, but it's a bit difficult to develop the thought process for this question. So I will mainly discuss about the thought process for solving this question. So basically what I did roughly, like I will go step by step, but let me go through the code, a complete code on a roughly a basis so that you will have the understanding what I'm going to when I'm going to understand explain the logic behind it. So in this we've initialized a vector which is a and initialize all of the values as 0. The length of the vector is k. This vector is basically finding out the modulo value, like how many times this subarray came, the summation of the subarray modulo k, which is like if the k value is 5, then the modulo value can range from 0 to 4, like 0, 1, 2, 3, 4. So this array is going to store that. Then we are also initialize some variable and answer variable. The answer variable is going to count the number of times we found the subarray, and some variable basically going to find out the prefix sum of the array till now, till the current iteration basically. Now we initialize a of 0 as 1. This is just to ensure if the current prefix sum modulo k, if the current sum is already divisible by k, then we found a subarray which is like divisible. So for this question, basically I did is iterate through each elements and then start to find the prefix sum. And then I found using this variable, I found out the modulo value of that sum. Then if that modulo value has came and then first if it came first time, then initial we are not going to add anything because the initial value of all the modulos are 0. But if it came again, it means like we have found a subarray between the first time that we found and now we have found a subarray whose sum is divisible by k. So this is the rough outline of the code, but let me explain this code in a great detail through here. So this is basically explaining the logic behind the code. So what basically the logic is let me go through the example case that we have given in the question, which is 4, 5, 0, -2, -3, and 1, and the value of k is 5. So basically during the first iteration, the value of sum is 4. The value of the value of answer is obviously be 0 because we initialize it with 0. Now when we in this temp value, we are just finding out the modulo of some modulo 5, modulo k, which is 5, which is going to be 4. And now we are going to increase the value of current modulo value by 1. The reason why we are doing this is right now we have 4. This value is not divisible by k. But if we found another, again, this modulo value is 4, then we have found a subarray which contains the sum which is divisible by k. Let me go through other iteration, then it will get more clearer. In the second iteration, the value of sum is 4 plus 5, which is 9. And now the value of temp is again 4, which is 9 modulo 5 is again 4. Now, what we understand from this is like from the we have found this modulo again. It means the, between the first time that we found this modulo and now there is a subarray, there exists a subarray whose sum is divisible by k. That's why the initially the modulo value was 4 and now again the modulo is 4. So there has to be some array, subarray in between whose modulo value is 0. Modulo value is 0. It means like the sub array is divisible by k. So that's why we increase the value of answer by 1 here. And we again increase the a of 4 by 1. The reason being, if we found this subarray again, then it means there are 2 subarrays inside in between the last time and the now. uh, um, there will be two values, two subarray that we need to increase it from. It will get more clear as we go through the next iterations. Now, in the iteration, uh, in the third iteration, as you can see, we have found 4, 5. Now 0 has came into the picture. So now sum is again is going to increase from the previous sum value plus the new element of the array, which is 0. So again, the sum value is again 9. Now, when we found 9 modulo k, which is 5, 9 modulo 5 is 4 again. That's the value I have stored in the temp variable. Now, again, we have found this 4. Now, we are going to increase the answer. We have found 2 subarray basically. That's why we are increasing the value of an answer by 2. The reason being, like between the last point where the modulo value was 4 and now we have found a new subarray which is whose sum is divisible by 5, which is 0. Plus, we are going to increase. We are going to find there is another subarray which can be formed by including the previous subarray plus the new subarray, which is 5 that we had initially and the new subarray which is 0. So we are going to add these two. We are going to count these two, like that's why we are increasing a of n value by 1 each time. The total number of new subarray needs to be added is equal to the 1 plus the number of previous subarray including the new subarray. 1 is because because of the new subarray excluding the previous subarrays, and we are including a of 4, like the number of previous subarray including the new subarray. This logic is going to get more clearer when we move on to the iteration 5. So let's proceed. During iteration 4, now minus 2 comes into the picture. Now the value of sum is sum plus of minus 2, which is 7. Now if we found the modulo of 7, we are going to get 2. Now 2 is a new number, new modulo value, because initially the value of 2 was 0. So we are not going to increase the value of answer by any number, but we are going to increase the value of a of 2 by 1. The reason being, if we found a of 2 again, then it means from the current position till the time when we found the again new when we found the a of 2 again, we will have found a subarray whose sum is divisible by 5. Let's move on to iteration 5. So this is the very important iteration which will make our logic of this question much clearer. So in the iteration 5, minus 3 comes into the picture. So now the sum value of sum is 7 plus of minus 3, which is 4. Now again 4, we have found the modulo value of 4 modulo 5 is 4. Now we have again found 4 again. Now what's going to happen? Now we are going to add 3, which is like the new, we have like last time we found a of 4 when we were in iteration, the third iteration. Now in fifth iteration, we again found a 4. It means between those, as you can see here, this between the last time and the this time, we have found again a new subarray whose sum is divisible by k, which is 5. Now this plus the previous plus new array, we have to add 2 more, which is including this new subarray plus the previous ones that we had. That's why we are increasing a of temp value by 1 every each iteration. So which is minus 2 minus 3. This is the new subarray plus these two are the previous one, which is including just 0, minus 2 minus 3, and including 5 as well, because initially we had 2, which is 5 and 0. So including these two. So that's why the value is 3. So now again we are going to, there is a little bit more iteration 6 is also very important, because in iteration 6 we found the value of 1, and the value of sum is going to increase from 4 plus the new element, which is 1. The sum is 5. Now 5 modulo 5 is 0. So this temp variable is 0, which was storing the modulo value. Now we are going to increase the value of answer by a of 0, and I initialize a of 0 as 1. The reason being, if we have found a of 0 at any point in time in the iterator in the question, then a of 0 itself means that summation of those subarray starting from initial till now, this subarray is a subarray whose sum is divisible by k. That's why I'm going to initialize this value as 0, because a of 0 doesn't have to come again to to increase that value by 1, because a of 0 itself, whenever it comes, it means we have found a subarray whose sum is divisible by k. That's why we initialized it by 0. That's the only thing, important thing here. And we are going to increase the value of e of 0 by 1, but that doesn't matter because our array has come to an end. And finally, this all the summation of answer value is going to be 6 plus 1, which is 7, and we are going to return the final answer variable, which is 7. So this was the logic behind this code. I hope this code makes sense, and the explanation as well. If you found this video helpful, don't forget to like, subscribe, and drop a comment with your thoughts or questions. Keep coding, guys. See you in the next video.